Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to discuss all the different types of angles you need to know in order to be successful on the Mathematics Knowledge Subtest of the Armed Services Vocational Aptitude Battery. More specifically, I'm going to start today's video by talking about those 6 definitions, and then in the second half of this video, I'm going to work out 8 practice problems that should closely mirror what you'll see on the ASVAB. So all that said, let's go ahead and get started. As you can see, the first definition is for an acute angle, and an acute angle is one that is less than 90 degrees. If you take a look at this example, you can see you have a 46-degree angle, which is in fact less than 90 degrees. Then we have a right angle, which is an angle that is exactly 90 degrees, and more often than not, that's denoted with a symbol that looks like this. Looks like a square almost. Then we have a obtuse angle, which is an angle that is greater than 90 degrees and less than 180 degrees. In this example, we have a 130 degree angle, which of course is greater than 90 degrees and less than 180 degrees. And finally, we have a straight angle, which is an angle that is exactly 180 degrees. More often than not, people refer to straight angles as straight lines, and so just bear in mind that those two terms are in fact interchangeable. I know I use the term straight line when referring to an angle that is 180 degrees. Of all the definitions in this video, these two are the most important. That is, you definitely want to understand the difference between complementary and supplementary angles, and as you'll see in just a minute, most of the questions in this video are in regard to these two definitions. Complementary angles are angles that add up to 90 degrees. Algebraically, that would look like this. Angle 1 plus angle 2 equals 90 degrees. We're going to make use of that in just a few minutes. Whereas supplementary angles are angles that add up to 180 degrees or straight lines. And algebraically, that looks like this. Angle 1 plus angle 2 equals 180 degrees. As it stands, you have enough information to solve the practice problems in this video. So in light of that, I recommend you attempt to work out these ASVAB questions on your own. That is, I strongly encourage you to pause the video after I read a question, attempt to work it out on your own scratch paper, and then resume playing the video to see if you and I came up with the same answer. Again, on the ASVAB, you're not allowed to use a calculator or a formula sheet, so try not to use those resources as you work on these practice problems. All that said, let's go ahead and get started. Number 1 says, which of the two angles are supplementary? If we recall the definition from above, supplementary angles mean angle 1 plus angle 2 add up to 180 degrees or a straight line. So in order to solve this one, we're simply going to add these up, and whichever pair adds to 180 degrees, we'll know that that's our pair of supplementary angles. 60 plus 90 is easy enough to do mentally. That's 90 degrees. So we know these are a pair of complementary angles, so that's not the correct answer. 41 and 139. Let's go ahead and work that off to the side. 139 plus 41. 9 plus 1 is 10. Carrier 1. 3 plus 4 is 7. Plus 1 is 8. And 1 plus nothing is just 1. So we can see that these two angles do in fact add up to 180 degrees. Therefore, we know they are supplementary angles. And of course, that's the answer to this question. Okay, so that was the first one. This next question says, which two angles are complementary? Again, according to the definition that I mentioned above, that means that the two angles add up to 90 degrees. So as we just did above, we're going to add these up and see which pair add to 90 degrees. As we can see, 30 plus 130 is going to be 160. That's greater than 90 degrees. 20 plus 160 is 180. That's greater than 90 degrees. And 45 plus 145 is 190. So that's greater than 90 degrees. And finally, we have 1 degree plus 89 degrees, which is in fact 90 degrees, which meets the definition of being complementary. So we know that is our answer. Okay, so pretty simple questions to start today's video. Now let's pick up the pace a little bit. Question 3 says 2 angles are complementary. If one of the angles is double the other angle, find the 2 angles. Okay, so again, I'm going to start by writing down the definition, the algebraic definition of complementary angles. That is, angle 1 plus angle 2 equal 90 degrees. Okay? And now I have to convert this word question into a formula that's going to let me solve for an unknown variable. In this case, there are 2 unknown variables. So I'm going to let one variable or one measure of one angle be x. And according to the problem, the other angle is double that. So that's going to be x plus 2x equals 90 degrees, where x refers to the measure of one angle and 2x refers to the measure of the other angle. And since they're complementary, we know they add up to 90 degrees. Now it's just a matter of solving for x. That is, eventually we want to get x equal to something by itself like that. So as you can see, we're going to combine these like terms to start, namely 2x and x, which is going to be 3x equals 90 degrees. Now we're going to divide both sides by 3, which will give us x by itself. This is going to cross out, leaving us with x equals 90 degrees over 3. This is the same as 90 over 3. Again, all fractions can be regarded as long division. So again, 90 over 3 is the same as 90 divided by 3, which looks like this here. Now we're just doing this long division. We should see that 3 goes into 90 30 times. 30 times 3 is 90, so there's no remainder there. So x in this case equals 30 degrees. Again, look how we paired this up. We have x corresponding to the measure of one angle and 2x corresponding to the measure of the second angle. So that looks like this. Angle 1 equals x, which equals, as we just found out, 30 degrees. So we know the measure of one angle is 30 degrees. And similarly, we know the measure of angle 2 is 2x, which is the same as, and I'm going to plug in x in place of x in this equation. It's going to be 2 times 30, which is going to be 60 degrees. So we can see the measure of these angles is 30 and 60 degrees, respectively. And if you add 30 and 60 together, you can see that that does in fact equal 90. Okay, so that was number 3. That's a very common question you'll see on the ASVAB. Question 4 says 2 angles are complementary. If one angle is 2 times the sum of the other angle in 3, find the 2 angles. So first, I'm going to write down what I know about complementary angles. That is, angle 1 plus angle 2 will be 90 degrees since they're a complementary pair of angles. Now I have to take this word problem and convert it into an algebraic expression that will allow me to solve for x. Not surprisingly, I'm going to start by referring to one angle as x. And it says if one angle is 2 times the sum of another angle in 3. So that would be x. So 2 times the sum of the other angle plus 3 equals 90. Okay, so I just took this part of the word problem and expressed it algebraically. So now we just have to distribute this 2 to this x and this 3. We'll combine like terms and then solve for x. So let's go ahead and do that. We have x plus, and again, this is going to be 2 times x, which is 2x, and then 2 times 3, which is 6, equals 90 degrees. Let's combine like terms, notably x and 2x. X and 2x is 3x plus 6 equals 90 degrees. All right, let's, again, we're trying to solve for x by itself like that. So as my next step, I'm going to subtract 6 from both sides. This is going to cross out, leaving me with 3x equals 90 minus 6, which is 84. Now I'm going to divide both sides by 3 to finally get x by itself. This is going to give me x equals 84 over 3. As you may recall, we can regard fractions as long division. So this is going to be 84 divided by 3 like that. And unlike the previous problem, this one's not as straightforward to do mentally. So we're going to have to work this one out via long division. Now we're asking ourselves, how many times does 3 go into 8 without going over? 3 times 2 will give you 6. So 8 minus 6 is going to be 2. You drop down this 4. Now we're asking ourselves, how many times does 3 go into 24 without going over? It's going to be 8, given that 3 times 8 is 24. So we can see there's no remainder there. And x, therefore, as we can see, equals 28 degrees. All right, so the way I set this one up should make sense now. Remember, I said one angle corresponds to the value of x, and this other angle, which I'm going to use green to highlight, angle 2 corresponded with 2 times x plus 3. So let's go ahead and write those out accordingly, and we'll have our answer. So again, angle 1 corresponded with x. And as we know, x is 28 degrees. So I know one of these angles measures 28 degrees. And if you look at the answers, you can see that only one of them has 28 in it. So we know this is the right answer choice. That said, let's keep working this out. We have angle 2. If you take a look right here, you can see angle 2 corresponds with 2x plus 3. And of course, we know x, so we can take this x and plug it in accordingly. So this is going to be 28 plus 3, which is the same as 28, 29, 30, 31. This is the same as 2 times 31. 2 times 31 is 62. Okay, so that's that one. Pretty straightforward. Hardest part about this problem was taking the word problem and converting it to an algebraic expression. Okay, and more often than not, that is the case. So just bear in mind that that's going to take some practice to get good at. All right, let's take a look at number 5. It says 2 angles are supplementary. If one angle is 36 degrees less than twice of the other angle, find the 2 angles. And let me get rid of this little mark right here real quick. So again, we know we're dealing with supplementary angles. So to start, I'm going to write this down. Measure of angle 1 plus the measure of angle 2 is going to be 180 degrees. And let's go ahead and try to write an algebraic expression that mirrors what's going on in this word problem. It says if one angle is 36 less than twice of the other angle. So I'm going to let one angle be x, which means the other angle is 36 degrees less than twice of the other angle. So that means this one's going to be 2x minus 36. Of course, that all equals 180 degrees. So now we're just going to combine like terms and try to solve for x accordingly. As you can see, we have like terms x and 2x. So this is going to be 3x minus 36 equals 180 degrees. Again, our goal is to try to solve for x by itself like that. So in light of that, the next thing I'm going to do is add 36 to both sides. This is going to cross out, leaving me with 3x equals 180 plus 36. In case you can't do that in your head, there's no shame in working it off to the side. 0 plus 6 is 6. 8 plus 3, 8, 9, 10, 11. Carry your 1. 1 plus 1 is 2. So we can see we have 3x equals 216. Now let's divide both sides by 3 finally to get x by itself. This is going to cross out, leaving you with x equals 216 over 3. As you may recall, we can regard this fraction as long division. Notably, we can regard it as 216 divided by 3, And this one's pretty straightforward to do. Just take a look at this. 3 goes into 21 7 times. 3 goes into 6 2 times. Therefore, 3 times 72 will be 216. Okay, so you have to be able to see those patterns when they appear, because as you just saw, it's going to save you a tremendous amount of work. So we know x is equal to 72 degrees, and my pen does not like my 2. So if you've watched my videos, you'll see that my pen doesn't like my 2's for some reason. Let me do what I did above. Again, angle 1 corresponded with x, whereas angle 2 corresponded with 2x minus 36. So all we do is have to substitute x in accordingly, and we'll have our answer. Again, angle 1 corresponded with x, which is, as we can see, x is 72 degrees. So we know 72 degrees is the measure of one of these angles. Only one of these answer choices, fortunately enough, only has 72 degrees in it, so we know this answer is going to be C. That said, let's find the measure of angle 2. That's going to correspond with 2x minus 36. And of course, we can take this x and plug it in its place there. So this is the same as 2 times 72 minus 36. And we can work that off to the side if we need to. This is 72 times 2. 2 times 2 is 4. 7 times 2 is 14. So this is the same as 144 minus 36. So let's work that out if we need to. 4 minus 6 we can't do. We have to borrow. This becomes 3. This becomes 14. 14 minus 6 is 8. 3 minus 3 is 0. 1 minus nothing is 1. So we can see that this is 108 degrees. Okay? So that was that one. Let's move on to the next one. All right, number 6 says 2 angles are supplementary if the ratio of the measure of the smaller angle to that of the larger angle is 5 to 7. What is the measure of the smaller angle? And this should be a comma, not a period. That should be lowercase. So in this case, we know we're dealing with supplementary angles. So that is, we know both angles are going to add up to 180 degrees like that. That said, we're given this ratio of 5 to 7. Well, that's simple enough. If this angle's 5x, that means this other angle is going to be 7x. Okay? So that's all there is to doing problems involving ratios and angles. Again, if it's the ratio 5 to 7, you can simply put an x in that ratio and then plug it into the equation, and it's the same thing. The ratio is going to be proportional in this equation. Okay, so with that done, let's go ahead and move on. And again, this is somewhat of a tricky question because it throws the ratio at you. And you may notice that as we go down, as we get to the 6, 7, and 8, the questions are getting more difficult, and that's expected. So now let's just combine like terms and solve for x. Again, we want to get x equal to something by itself like that. 7 plus 5 is 7, 8, 9, 10, 11, 12. X equals 180 degrees. Divide both sides by 12 to get x by itself. This says x equals 180 divided by 12. And in case you haven't realized it yet, you can regard this fraction as long division, notably 180 divided by 12. This one's not obvious, so we're going to have to work it out. Now we're asking ourselves, how many times does 12 go into 1? It doesn't. How many times does 12 go into 18 without going over? That's going to be 1 time, so I'm going to place the 1 over the 8 there. I'm going to subtract out the 12. 18 minus 12 is 6. Drop down this 0, of course. 12 goes into 60 5 times. 12 times 5 is 60. So we can see there's no remainder. So this is going to be 15 degrees. And in this case, let me do a different color so I can highlight it. Angle 1 corresponded with 5x, whereas angle 2 corresponded with 7x. With that said, this question's just asking us to find the measure of the smaller angle. So we're going to plug in 15 for x, and 15 times 5 would be smaller than 15 times 7. So angle 1 is clearly the smaller angle. So this is going to be angle 1 equals 5x. Let's take that x and plug it in place of x over there. It's going to be 15 times 5. In case we can't do that in our head, let's work it off to the side. 15 times 5. 5 times 5 is 25. Carry your 2. 5 times 1 is 5 plus 2 is 7. So we can see the measure of this small angle in this supplementary pair of angles is 75 degrees. Okay, so that's that one. Let's go ahead and do number 7 and 8, and then we'll be done with this video. If you've followed along with everything we've done in this video so far, you're in great shape for the ASVAB. These final 2 questions are just tricky questions, and I included them in case you do see something like them on the ASVAB. Your chances of seeing them are about 5% or less, so don't panic if you don't understand these last 2. All right, question 7 says, the measure of an angle is 14 degrees less than the measure of its complement. Find the measure of the 2 angles. So this one has a much different setup than all the previous problems. It says the measure of an angle, which I'm going to call x, is 14 degrees less than the measure of its complement. I have to find a way to represent that algebraically. Is 14 degrees less than the measure of its complement? Well, we know complementary angles add up to 90. Therefore, I know the complement of angle x is going to be 90 minus x. So I just represented its complementary angle algebraically. If this is x, its complement is 90 minus x. And then we're told additionally that this angle is 14 degrees less than that. So that's going to be minus 14. Okay, so this is the setup to this one. Okay, so in light of that, you can see we're just solving for x now. And that means let's go ahead and simplify this. These parentheses really don't do anything other than to illustrate that this is the complement of x. So this is 90 minus x minus 14. I'm going to combine these like terms, notably 90 and negative 14. So this is going to be 90 minus 14. 0 minus 4 we can't do, so we're going to have to borrow. This is going to become 8. This is going to become 10. 10 minus 4, of course, is 6. 8 minus 1 is going to be 7. Okay, so this becomes x equals 76 minus x. Again, we want to get all the x's to one side like this. That is, we're trying to solve for x. So I'm going to add this x to the other side. This is going to cross out, leaving me with 2x equals 76. Now I got to divide both sides by 2 to finally get x by itself. So this gives me x equals 76 divided by 2. Again, we're going to regard this as long division. So 76 divided by 2. And in this case, this one's not obvious. So we're going to have to work it out as we normally would doing long division. 2 goes into 7 3 times without going over. 2 times 3 is 6. Let's subtract. 7 minus 6 is 1. Drop down to 6. 2 goes into 16 8 times without going over. 2 times 8 is 16, so we can see there's no remainder. In this case, x is 38. So in this case, we know x represents the measure of one angle. So we know one angle is 38 degrees, and the other angle is simply going to be 90 minus 38 degrees. So this is angle 1. 90 minus 38 is going to be 0 minus 8. We can't do. We have to borrow. This becomes 8. This becomes 10. 10 minus 8 is 2. 8 minus 3 is 5. So the measure of angle 2 is 52 degrees. So these two angles are 52 and 38 degrees respectively, okay? And this setup was much different than anything we've seen in the videos so far. Number 8 says the measure of an angle is 6 degrees more than twice the measure of its supplement. Find the measure of two angles. So in this case, we know we're dealing with supplementary angles which add up to 180 degrees. That said, we have to find a way to represent this one algebraically. That's going to let us solve for x. So I'm going to write x equals, again, we know the measure of an angle is 6 degrees more than twice the measure of its supplement. Okay, so let's start by representing its supplement. If one measure of angle is x, its supplement is 180 minus x. And in addition, we're told that it is twice the measure of its supplement. So we're going to put a 2 right there. And 6 degrees more than twice the measure of its supplement. So that means we're going to add a 6 here as well. Okay, and just like that, I represented this word problem algebraically, which is going to enable us to solve for x, which will enable us to find the value of these two, the measure of these two supplementary angles. So let's start by distributing this 2 to 180 as well as negative x. 2 times 180 is 360. 2 times negative x is negative 2x. Then we have this plus 6 hanging out at the end there. So let's combine like terms. This is going to be x equals 360 and 6 are like terms. They're whole numbers more specifically. So this is going to be 366, given that 360 plus 6 is 366, minus 2x. Again, we're trying to solve for x like this, x equal to something by itself. So to do that, let's move this 2x to the other side of the equation via addition. This becomes x plus 2x, which is 3x, equals 366. Again, negative 2x plus 2x just crosses out. And as you can see, for our final step, we're going to divide both sides by 3. This is going to give us x equals 366 over 3. That is, we're going to regard this fraction as long division, notably 366 over 3. And this one's pretty straightforward. 3 goes into 3 one time, 3 goes into 6 two times, 3 goes into 6 two times. Therefore, I know 3 times 122 is going to be 3. What is up with my pen? 366 even. So there's going to be no remainder. Okay, so in other words, the measure of one angle in this case is going to be 122 degrees. And again, these are supplementary angles. So if one is 122 degrees, to find the other one, I'm going to subtract 122 from 180. And if we take a look at our answer choices before we do that, we can see only one has 122 in it. So let's do this just to confirm that this is in fact correct. 0 minus 2 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 2 is 8. 7 minus 2 is 5. 0 minus 0 is 0. So we can see our two angles are 58 degrees and 122 degrees respectively. All right, so that's it for today's video. I hope you found it helpful. As I mentioned at the start of this video, you absolutely need to know the definitions of these different types of angles. Above all else, you need to know how to manipulate the definitions of complementary as well as supplementary angles algebraically. You will absolutely see a question like that on the ASVAB. So in light of that, I ask that you consider subscribing to my channel if you think my content's helpful. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.